Okay. Did you get your preparation done?
Yeah, I tried to get most of it done.
Okay.
Yes.
All right. So I'm a little bit pressed for time this morning, so let's go ahead and just start the quiz if you don't mind.
Okay.
I've looked over it, the first part of it so far, and it's not too hard. I'm not loving this section. All right, we'll start with number 3. So which hypothesis involves equality? And that's the null hypothesis.
Okay. That makes sense.
Number 4.
Okay, number 4. When computing the p-value, the alternative, I think.
I think it's the null hypothesis because wait, let's see. Now you made me think because.
I believe they said never to assume.
Because when you stated it, you say that the null hypothesis equals the mean. So you're trying to disprove that, but I still think it's the null hypothesis.
Okay, I just remember in the lesson it said never to assume the null hypothesis is true.
Well, it says that we can never prove that it's true. We can only prove that it's not false, something like that. But I think that we assume, I'm going to go back really quick. Because we're saying in the hypothesis that it equals the mean. So we're assuming that it's true, but we're trying to disprove it.
Oh, I see.
That's my understanding of it. I'm going back up to really check here. Yeah, it says when we test hypotheses, we assume the null hypothesis is true. So there. We figured that out unequivocally. All right, number 5. Which of the following represents the alternative hypothesis for a two-tailed test? So that can be greater than or less than. So it's the HA where the mean is not equal to 10.
I see it.
All right, number 6.
For the left-tailed test.
So that would be for a lower number.
So I think it's the one with the less than sign.
Yeah. I believe that is true. And then the next one's for the right-tailed, and that's greater than 10. All right, number 8.
Okay. Okay, we failed. I believe we failed to reject the null if P is less than A, I think. Is that right? P is less than A, we reject the null. No. If P is greater than A, we fail to reject the null hypothesis.
Correct. That's what I got anyway. Because the smaller the probability, then the more likely that we reject the hypothesis, because it's not, from what I understand of that, there's not a great chance that could happen, that it would happen just by chance.
Okay.
The lower the probability of it. And then which relationship would result in rejecting the null hypothesis? That would be if it was less than A. We would reject or less than alpha, I guess. So p-value is less than alpha, we reject it.
Okay.
That means the smaller probability that it happens by chance. All right, number 10. Is actually higher than this. Okay. Which of the following would be the appropriate alternative?
Okay, I believe the alternative hypothesis is the average claim amount is greater than 1,500.
Yeah, that's what I would put. Which of the following would be the appropriate null hypothesis? That would be the equal to. So the average claim amount is equal to 1,500. Claims, calculates the sample mean. Use this information to answer the next 3 questions. You got number 12?
Yeah, I think it's a good assumption since the sample size is large.
Yeah, because don't we assume anything over 30 is sufficiently large?
Yes, I think we learned that in the last a couple lessons back.
Theorem or law justifies? That's the central limit theorem. It has to do with distribution. Okay, number 14.
So the following is the test statistics as defined by this lesson. I believe the test statistic is X.
Right. It's the sample mean that we're testing against the population mean. Right. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypotheses. Null hypothesis, the mean equals 150. Alternative hypothesis, the mean is less than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes sample mean to be 144. What is the z-score associated with this test? Okay, I have to compute that. So it would be 144 minus the 150 over 40 divided by the square root of 36. Let me do that on my calculator. That's 150 plus divided by 40 divided by the square root of 36. So I get negative 0.9 as my z-score. Going to the normal probability applet, I put in the negative 0.9. And then she wants to know if it's less than that. So I come up with a probability of 0.1841. Which is, where's my, oh, so the z-score, oh, they would just want to know the z-score. 0.9, so negative 0.9. I was getting ahead of myself. There aren't any 3 places. I'll put a couple of zeros in there just, you know, to say. All right, so what is the p-value?
Okay, the p-value. Is more extreme. The p-value.
We have to get that in the normal probability applet, right?
Yes.
And I think we highlight the to the left of the negative 0.9.
Just give me a second to try and get it up.
Sure.
Okay. Okay. Okay, and everything left of it is 0.184.
Yes. It is what I got. I'm hoping that that's correct there. All right, so then what inference would you make about the null hypothesis for this problem? The alpha was supposed to be equal to 0.05. The 0.184 is larger than that, so we would fail to reject the null hypothesis. And number 18.
Yes. We have insignificant evidence that the mean is less than 150.
Yes. Yes. You are right. There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the hypothesis is true? That's type 1. number 20.
Let's see, I think the probability of making a type 1 error will increase in this one.
No, if the alpha is too low, it's a type 2 error that can occur.
Oh, that's right. Type 1 is when it's too large.
Yeah, I know. It's so confusing.
Okay.
And then the final question, if alpha is 0.05, compute the probability of a type 1 error. It would be 1 in 5, which is 0.05, I think. No, 1 in 5. 1 in 50. No, 1 in 20. Huh? Wait a second. I think it says here. Hold on. Because it's 5 100ths. Yeah, so that would be 5 100ths. I think that's just the 0.05. It's 0.05. It's like a trick question.
Okay.
Right? It's 0.05. Well, let's see if that's right. I hate when they do that because then I think, well, am I missing something here? That's okay. Let's see how we did here. So far, so good. Okay, so we got question number 14 wrong.
Okay.
Which of the following is the test statistic? I now have to go back and look at that. Assuming the null hypothesis is true, we assume that the true mean body temperature is wanting to test the claim. Researchers collected data. The mean of the observed values X. Okay, so his.
Oh, that's the same.
Oh, I guess it's the z-score. It says since we know the standard deviation in this case, we can use the z-score to determine if the sample mean is far from the assumed value. This is called the test statistic. So it's the z-score that's the test statistic. Okay. So you can we're allowed to take it twice. So you can just go back and change that one if you care to. The rest of them we got right. So
okay.
If you care to retake it, you can go ahead and do that. Otherwise, we'll just go from there.
Okay.
All right. So next Tuesday, same time, same place. After next week, would you be able to meet an hour earlier?
Yes.
So it would be 8 o'clock your time, because you're on Pacific time, right?
Yes.
Okay. So I'm going to check with Cammie and Alex, and then I'll just send an email letting you know if we're going to, my kids will be out of school, so it'll be a little easier for me to go earlier. But I'll let you know. But next week we'll just, and maybe everybody will be able to meet next week, and we'll be able to see if everybody's able to change the time. And we'll go from there.
Okay.
All right. Have a nice weekend.
I will. You too.
Take care.